ice, water, gas. What separates these three states of water? Hydrogen bonds. T.S. Moore and T.F. Windmill were the first scientists to discover hydrogen bonding in 1912. Hydrogen bonding is interaction involving a hydrogen atom located between a pair of other atoms having a high affinity for electrons. The atoms that have high affinity for electrons and are capable of hydrogen bonding are fluorine, oxygen, and nitrogen. The hydrogen atom has a partial positive charge, which is attracted to the negatively charged electrons. Atoms such as fluorine, oxygen, or nitrogen have a high electronegative charge, meaning they can attract these hydrogen atoms. For instance, this red ball represents a hydrogen atom, and these black sticks represent the oxygen atom. Put together, they make a water molecule. When more than one water molecules are around each other, they are capable of hydrogen bonding. These bonds are not a full-on sharing of electrons, so they are not permanent, but with a large number, they are quite strong.
These bonds can be broken when energy excites the molecules, such as heat by the sun or some other source of energy. This can be demonstrated with water. As described in an article produced by the BYJU Chemistry, in a low-energy environment, it is a solid, and its molecules are in a tight formation and move very little because there is a lot of hydrogen bonds formed between them. In a higher energy environment, it's a liquid, and its molecules are in a looser formation where there are less hydrogen bonds, so the molecules are allowed to move in a more fluid manner. In a very high energy state, it is a gas, where there are no hydrogen bonds at all, so the molecules can move freely without really interacting with each other. Let's think for a second. What if hydrogen bonds didn't exist?
When a huge catastrophe that could occur would cause in DNA. In an article published by the National Human Genome Research Institute, it described how DNA utilizes hydrogen bonds to keep its base pairs together. It needs this to happen so that it can translate the information so it can be transferred over to the biological molecules such as proteins.
For example, this is an adenine molecule, which pairs with thymine molecule through hydrogen bonding. The same thing happens to cytosine and guanine, which are the other two building blocks for DNA.
With hydrogen bonding, DNA is capable of building the double helix formation, which allows it to store someone's genetic information. If DNA didn't have hydrogen bonds, it wouldn't be able to make this formation and it wouldn't be able to properly function. If it couldn't properly function and store our information, then biological life wouldn't be able to exist at all.
These little lifesavers are essential for our lives to function normally.